When you hear nuclear power plant, where does your mind go? Does it go to the safety, sustainability, and efficiency of nuclear power? Because that's where a lot of people's minds will go. A lot of people question the safety of nuclear power due to past accidents like 3 Mile Island and Fukushima, but these accidents have been studied and researched heavily to avoid future accidents. And if you're wondering if they're safe and sustainable, I would like to point out that since 1954, the U.S. Armed Forces have been using nuclear power. That's over 70 years. So, the technology and reactors have been studied for over 70 years, and they've been advanced so much since the first reactor in 1942, Chicago Pi 1. Chicago Pi 1, it was simply a test reactor. It was not power producing, and it was so small it didn't even require a coolant system. So, who am I? I'm Kate, and I'm a senior nuclear engineering student, and I study nuclear engineering for fun in my free time. That's what I research. That's what I watch in my free time. And I also have family and friends who have operated nuclear power plants and naval subs. So, over 70 years of advancement in nuclear power, and today I'm going to go over 3 reactors: light water reactors, high temperature gas reactors, and sodium cooled fast reactors. So, first, let me start off with the most common reactor, a light water reactor. I'm going to talk about the research, the coolant, moderator, and the shielding. So, according to the World Nuclear Association in 2026, 80 to 90% of all nuclear power plants are light water reactors. With that, about 70% are pressurized water reactors, and the other 15% is boiling water reactors. And they've been researched for over 70 years. And the coolant and moderator of light water reactors is in the name. It's water, H2O. According to the Department of Energy in 2015, the excess heat from the reactor core is removed through water. Water is the coolant. And water is also the moderator. And water is able to slow neutrons, so we are able to control the power that is being produced. We're able to control the amount of fission. This makes the reactor safe and efficient and sustainable. So, now let's talk about the shielding. So, in 2015, the Department of Energy said that these reactors operate at a pressure of 7 to 15 megapascals. And H2O, it's honestly not that good of a shield, okay? So it allows neutrons to escape, and that is not good. That's what radiation is neutrons escaping. So with that, we have to have a thick concrete shield. So that's the shield. So light water reactors are the most dominant reactor. Now let's talk about a test reactor, high temperature gas reactors. So high temperature gas reactors, I'll talk about the fuel, the downsides, and their versatility. So first, their fuel. It's called tristructural isotopic fuel, TRISO fuel. So the Department of Energy had a research paper published in 2019 talking about TRISO fuel. TRISO fuel, it's a small pellet. It's 1 millimeter in diameter, and it's made of uranium, carbon, and oxygen. And it's able to withstand extreme temperatures, and that's why it's the fuel. So this is a diagram of what it looks like. So the extreme temperatures of these reactors is the biggest problem. They operate at about 750 to 950 degrees Celsius. So the Oak Ridge Lab in 2021 did research on what coolants they could use. Initially, they were thinking CO2. But CO2 is only able to withstand 650 to 700 degrees Celsius. That's not enough. We need a better coolant. So Oak Ridge Lab has transitioned into helium coolant. Helium coolant is able to withstand the extreme temperatures. So that's the new coolant. And the versatility and efficiency of these reactors is insane. A single reactor can produce up to 625 megawatts of energy, according to the Department of Energy in 2021. And with that, the versatility side of it, you do not need to shut down the reactor to refuel it like many other reactors do. You can refuel it while it is still active. That's a huge plus to it. So, moving on from this test reactor, let's talk about a reactor that has 2 commercial operating reactors. 2 operating commercial reactors. So, while sodium cooled fast reactors, they have 2 operating commercially, they are also a test reactor still. So I'm going to talk about their versatility, coolant, and efficiency. They have been being studied since the early 1950s. And Generation 4 International Forum is the largest group doing research on these. So this is where I got most of my information. So the fuel, it has multiple different fuels. It's versatile. But the main fuel that is used is uranium plutonium oxide. This is the main fuel, but you can also use other fuels, such as metallic uranium plutonium zirconium fuel. While these are just two of the fuels that can be used, but there is a long list of other fuels that can be used for this. And the coolant. So according to the Department of Energy in 2021, the coolant is liquid sodium. But the problem with liquid sodium is that it reacts to air and water. So because of that, we have to seal the reactor insanely tight. We can't have any other reactions outside of what we want, which is just the fission inside of the core. So with that though, sodium is also not a very good shield. It does not slow down neutrons. So we need a good shield yet again. So is it safe and efficient, you may ask? Yes, according to Generation 4 International Form, the reactor core is 500 to 500 degrees Celsius, and liquid sodium is able to withstand up to 880 degrees Celsius. So it's safe. With that, the efficiency, it's able to produce 30 to 1500 megawatts of electricity, of energy. That's a lot of energy from one reactor. And another plus to this is that they're safe. They operate at atmospheric pressure, so you don't have to worry about the high pressure in it. There is no high pressure. It is just atmospheric pressure. So, moving on from sodium-cooled fast reactors, I talked about their versatility, their coolant, and their efficiency and sustainability. So, let's recap. Today, I went over light water reactors, I went over high-temperature gas reactors, and I went over sodium-cooled fast reactors. So, first, the light water reactors are the most common, and I went over a few key components of them, their coolant and whatnot. Then I talked about high temperature gas reactors. These are test reactors, none commercially operating. I talked about their fuel, their challenges, and their efficiency. Then I talked about sodium-cooled fast reactors. I talked about their fuel, their coolant, and their versatility. So today, with this information, I hope that you guys stay open-minded to nuclear power, and I hope that you guys now have a better understanding of nuclear power plants and the different reactors. These are my note cards. I hope they're